Hey guys, welcome to one of our final lessons here in this unit. We talked about vertex form yesterday and how you can use vertex form to actually figure out what the vertex is, or if you wanted to, describe how the parabola shifted left, right, up, or down. Well, today we're going to take I'm going to challenge you a little bit. I'm going to ask you to take an equation that's in standard form and actually turn it into vertex form, convert it. Now, there's a lot of algebra involved in this. And this is a video that you're probably going to want to rewatch, pause. Well, you can't do slow motion, but slow it down a little bit the best that you can to kind of follow all the steps that I'm going to do. Okay. And some of this involves factoring, which we did previously. Okay. Now, the difference between the two forms of quadratic we've learned so far is standard form is up there. That's your typical trinomial, ax squared plus bx plus c. Then we have vertex form, which sort of has the x part in parentheses, okay? And that whole parentheses is squared. And then we have our plus k. And we know that the h and the k make for our turning point, or our vertex, whatever you want to call it. So our goal today will be to take an equation written like this and write it like this. Transform it. Okay. Now, I like this lesson because it's kind of fun. But again, there is some detail to it. So please, 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 if you need to stop, rewind the video, please go ahead and do that. Okay. Now, there's some writing up there. It says when converting quadratics into vertex form, you'll need to create perfect square trinomials. I'll tell you when we get to one of those and what it looks like. But what we're going to do today is something called completing the square. You're going to hear this in your algebra class a lot. Okay. And it's a process by which you change an equation to create those perfect square trinomials. A lot of stuff I just said, but bear with me as we go through this, and maybe even I'll post a step-by-step for you if you need to. All right, first thing we're going to want to do in order to transform this thing is we're going to bring the constant, this thing here, to the other side. Now, in order for us to do that, we have to do it algebraically. So I can't just move it over there. I'm going to have to do it mathematically. So since it's a -1, I'm going to do +1 on either side. So now I'll be left with x squared minus 4x is equal to y plus 1. Okay. We'll come back to that in just a second. Now, we are about to complete the square. Now, when we complete the square, here's what you do. You take the b value, in this case, -4. Okay. Cut it in half. Okay, that gives me -2. Then square that number. Okay, now, when I square -2, be careful, put it in parentheses. -2 squared is equal to 4. Now, what I want you to do is add that number to each side here. So +4 and +4. You have to do it to both sides, otherwise you don't keep that equation balanced. And when we do, we end up with y plus 5 is equal to x squared minus 4x plus 4. Now, if you're asking yourself, what was the purpose of doing what we just did? Well, what it did was this created for us a trinomial whose factors, when I go to factor it, are going to be exactly the same. When I go to factor this thing, the factors are x minus 2 and x minus 2. So that's our next step, factor this thing. Those two numbers multiply to be +4. They combine to be -4, the number in the middle. So that's how it factors. Now, instead of me writing it that way, though, I'm going to write it as x minus 2 and then put that thing in parentheses squared, because x minus 2 times x minus 2 is x minus 2 squared. So let me erase that. And instead of writing x minus 2 times x minus 2, let me write it as x minus 2 squared. And I think you can see why I want it to look like that, because in the next step, when I subtract the 5 back to the other side, look what I end up with. And I'm going to run out of room, so let me write it right over here. Y equals x minus 2 squared plus 5. That thing is now in vertex form. Awesome. The vertex would be 2, 5. And we did that by what we call completing the square. It's quite a process, I know. Probably going to want to go back and rewatch this one again. We'll do a couple more together, but that's how you transform an equation from standard form into vertex form. I think maybe the hardest part there is the factoring part. But if you know that it factors into two things that are the same, that makes it a little easier. All right. Pause, go back, rewind if you want. I'm going to move right into the next one. Okay, so here's two more for us to sort of watch so that you can practice. All right. Remember, first step, bring the constant to the other side. So plus 2, y plus 2 is equal to x squared plus 6x. Now I take my b value, which in this case is 6. Divide it by 2, gives me 3. Square that. And then add that to both sides. What that did for us, and I'm going to highlight this in pink again, is it created a trinomial, what we call a perfect square trinomial, a trinomial that factors into two things that are exactly the same. In this case, it's x plus 3 and x plus 3. But we're not going to write it that way. So let's take off that second one. We're going to write this as x plus 3 squared, because that is going to give us, in the next step, the equation in vertex form. There you have it, x plus 3 squared minus 11. And if someone said, well, what's the vertex? You'd tell them the vertex is -3, -11. Done. Converting it by completing the square. Okay, I'm not going to do a video for the whole next one. In fact, what I'm going to do right now is just skip right to the answer. So I'm going to delete this one here. If you need to, pause the video yourself. Now, pause the video, because in just a second, I'm just going to have the entire answer completed. Okay, well, there you have it. There is the final answer here, y equals x minus 1 squared plus 10. You can see in step 1, I brought the 11 to the other side. Then I took half of -2, which is -1, and I squared it. That's plus 1. So that's why you see that I've added plus 1 to both sides. I kind of wrote it up here this time, but that's my plus 1 to both sides. Factored that thing into x minus 1 and x minus 1, which I wrote as x minus 1 squared. Then I brought the 10 to either side, and y equals x minus 1 squared plus 10 when I brought the 10 back over. All right, well, there you have it. That is transforming into vertex form when you're in standard form. Okay, we'll probably do a couple of days of practice with this. It's not easy to get, but feel free again. Pause the video, go back, rewatch. There you have it.